This is Algebra 1, Unit 10, Lesson 3, Greatest Common Factor. After this lesson, you will be able to factor any polynomial by dividing out the greatest common factor. So we have here the factors of a number are two numbers that multiply together to get that number. So if I said, what are the factors of positive 8? You should be able to tell me 1 times 8, because that equals 8, and 2 times 4, because that also equals 8. Something else to keep in mind is the sign. When it's a positive 8, I can create positive by multiplying two positive numbers together. However, I can also create a positive by multiplying two negatives together. So there I have my other factors of -1 and 8 and -2 and -4. Now over here, when I'm looking for the factors of 6, hopefully you can think what goes into 6, 1 and 6, 2 and 3. But then I also have to look at the sign. Because the sign is negative, I know that I need to have a negative and a positive. So the first set of factors I have are -1 times +6, -2 times +3. What do you think the other two sets of factors could be? Hopefully you were thinking about switching the signs. We also could have had +1 times -6 and +2 times -3. All of those pairs multiply to -6, just like all of these pairs multiply to +8. Factors are the numbers that multiply to get that number. So we're going to take a look at this project first. Letter A, we want to list all the factors. So it's positive, so I know I need to have positive and a positive. Well, I know 1 and 25. 2 doesn't work. 3 doesn't work. 4 doesn't work. And 5. And of course, that would be times +5. Now, if I can use the positives, I can also use the negatives. -1 and -25, -5 and -5. Those all multiply to create +25. If I was to go ahead and do letter B, and I was thinking about the factors that multiply to a -16, well, I know that in order to get a negative, I need to have a positive and I need to have a negative. Well, I could have a +1 and a -16. I also could have a +2 and a -8. I also could have a +4 and a -4. Now, if I did the opposite pairings of those, that would be -1 and +16. I could also have -2 and +8. Now I could repeat the 4s, but I already have the pair +4 and -4. So the pair -4 and +4 would be the same thing. So there's all my factors that multiply to -16. Pause the video now as you complete problems C, D, E, and F. Do your best. You are amazing. Factors of -7 are +1 and -7, -1 and +7. The factors of +21 are +1, +21, +3, +7. And of course, because positives can also be made by the negatives, we also have the negative pairings of those factors. The factors of 80 are definitely a lot more. The bigger the number, a lot of times you end up with a lot more factors. Of course, we have from 180, 240, 420, 516, and 810. All of those would multiply to make 80. We have both the positive pairs and the negative pairs to make +80. And there you have the factors of -100. Of course, there's going to be a lot of these, but remember, when you're multiplying to a negative, you need both a positive and negative factor. Here we go. Now, when we're talking about greatest common factor, you hear the word greatest, and what comes to mind? Well, hopefully you're thinking things like largest, biggest, most. When you hear the word common, well, when I say I have something in common with someone, it usually means it's shared. It's something that's the same about us. It's something that's alike. Now, you have the greatest common factor. The factors we've just been talking about are the divider. What can I divide out of that number? Now, greatest common factor is the largest shared divider. So if we take a look at this first example, what is the greatest common factor, which we're going to call the GCF? So GCF is the greatest common factor of the following. We'll take a look at part A. What can I divide out of a 7 that I can also divide out of a 21? Well, if I look at the factors of 7, I know I can have 1 and 7. If I look at the factors of 21, I know I can have 1 times 21, and I know that I can have 3 times 7. Well, I'm looking for the largest number that they share. So if I look, I know they share a 1, but that's not the largest. So I take a look at 7. They both share it, so my GCF is 7 because that is the largest shared number. Pause the video now as you take a look at 14 and 12. See what the greatest common factor you can pull out of 14 and 12. Press play to go over your answer. So I know 14 is 1 and 14. I know it's 2 and 7. I know 12 is 1 and 12. And I know it's 2 and 6 and 3 and 4. So if I'm looking for the largest number I can pull out of both, I'm looking at 2. So I know my GCF right there is 2. But what I also need to keep in mind is that there are variables. Here, I have an x. So that's one of my factors. Over here, I have x squared, which I'm going to write out as 2 x's. Now, if I had to say what is the most amount of variables that they share, well, they both have 1 x I can divide out. So that is also part of my greatest common factor, my GCF. Pause the video now as you try example C. Press play to go over your answer. I know the greatest common variable for part C is going to be 2, and then I do the variables. This right here has 2 x's. And this one right here has 4 of them. So if I had to say the greatest common factor for my variables, it's going to be 2 x's that I can take from both. Now when I write x times x, it's written as x squared. One thing you might also notice is that when I have my smaller exponent, that typically ends up being in my greatest common factor. And if you notice again on this one, my smaller exponent was x, and that's how I end up with x, my greatest common factor. All right, let's dive into some problems. So now we have 5x minus 15. What can go into a 5 that can also go into a 15? Hopefully you were thinking 5. Now I could have written out the factors 1 and 5, 1 and 15, 3 and 5. But I already know from looking at it that it should be 5. So it's okay if you can get rid of this extra step by just thinking about what is the biggest number I can pull out of both. Now notice, not only am I going to write my GCF 5, but I'm also going to put 5 as a divider, as the denominator as a fraction, because I'm going to divide out my greatest common factor. What that will give me is 5 divided by 5 is 1. I have an x left over. Negative 15 divided by 5 is negative 3. This is my final answer. Now remember, you don't actually have to write the 1 because it creeps in the shadows. But what you see here is you have your GCF, and then you have your leftovers, or remainder, if we make it more mathy. So I need to figure out what goes into both of them, pull it out, divide it to see what's left over. Now, if you notice from the original problem, I didn't take out a variable. This one has 1x. This one has none, which is why I was not able to take out a variable for my greatest common factor. Pause the video now as you try example 3. Press play to go over your answer. Remember, you should be writing your greatest common factor, your GCF, and then whatever is left over. So the first thing I do is think about what number can I take out of a 3. I can also take out of a 12. 3 comes to mind. Now when I'm taking out a 3, I know that I can end up with a 3. That's going to leave me with 1 and positive 4. The reason I left spaces is because I know both of them have a variable. Well, I'm going to look to the smallest amount of x. Again, that represents how many x's they have. So if I'm looking to take out the smallest amount, I know I can take out x squared from both of my factors. So again, I can take out that x squared. Now when you're dividing exponents, hopefully you remember you're actually subtracting. 4 minus 2 is why we end up with x squared left over. 2 minus 2 is the reason why we have no x on the end of our answer. So there you have it, your final answer. Remember that you don't actually have to write the 1, even though that's what's left over. Pause the video now as you try example 4. Press play to go over your answer. Do your best. You are awesome. So now I'm looking at 24, 8, 12, and 14. Well, I know that I'm going to go to my smallest number, which is 8. Smaller numbers usually are going to have less factors. So I know this one is 1 and 8. I know this one is 2 and 4. If I'm looking at those, I know that 1 goes into everything, but it's not my greatest factor. I know 2 can go in, but I want to see if there's a bigger number. I check 4. Does 4 go into every single number? 4 doesn't go into 14. So my next one I can use is 2. So I'm going to divide everything by the factor of 2. And that's going to go on the outside of my parentheses. Now I'm going to look at my variables. I know I can go to my smallest one, and that is going to be part of my greatest common factor. When I'm finding my remainder, I divide the numbers. 12 and 2, 24 and 2 make 12. X to the 4th minus 1 is going to be x cubed left over. Another way to look at that is I had 4 x's, and I took away one of them. So that's how I end up with my x cubed left over. Keep it going. 8 divided by 2 is going to be positive 4. X cubed divided by x is x squared. It goes down by 1. Negative 12 divided by 2 is negative 6. X squared divided by x is just x. And last but not least, 14 divided by 2 is positive 7. X divided by x cancels, so that is my final answer. Pause the video now as you try example 5. Press play to go over your answer. Do your best. You're awesome. So I go ahead and look. I can take out 3, goes into 21, but it doesn't go into 14. I try and take out a 7, which goes into 14 and 21, but not 3. So then I take a look at my variables, and this guy has none, no x. So that means there is no greatest common factor. Just because they ask you to find one doesn't mean it's always there. And again, if I wrote out the factors, you can see that there isn't an overlap of every So that means I can't pull out a number. When looking at the variables, I have 2 of them here, 1 of them here, but 0 over here. So I can't take out any variable. So no GCF. Pause the video now as you try example 6. Press play to go over your answer. I believe in you. We take a look at our numbers. 2 is going to be the greatest common factor for the coefficients. My smallest amount of variable is none. So I know I can't take out any x's. So I find out what's left over. 2 divided by 2 is 1. So I'm just left with 1x squared. Remember, you don't have to write the 1. 8 divided by 2 is 4, and x comes down. And negative 24 divided by 2 is negative 12. And there you have it, your GCF and your remainder. Pause the video now as you try example 7. Press play to go over your answer. Stay awesome. Don't lose steam. Try your best. I expect nothing less. Okay, so let's take a look. We can take out a 5. We are left with 5. Now I can't take out an x because this one has none. So that's the reason why I'm left with 5 divided by 5 is going to be 1x squared. Negative 20 divided by 5 is negative 4. And that's my greatest common factor and my remainder. Pause the video now as you try example 8. Press play to go over your answer. So we take out on this one, it's a little bit harder to see, 27 and 14. I'm going to write my factors, 1 and 27, 3 and 9. That's kind of it. 1 and 14, 2 and 7. So there's no overlay other than 1. So that means there is no GCF. Pause the video now as you try example 9. Press play to go over your answer. This one might be a little more challenging, but I know you're up for it. So let's do the numbers first. 16, 8, 24. Well, I know 2 goes into all of them, so now I need to see if there's anything bigger than 2. Well, 3 doesn't work. 4 would go into all of them. All right, is there anything bigger than 4? Well, here's a way I can check. If I was to divide these all by 4, I would end up with 4, and then I would end up with 2, and then I would end up with negative 6. Well, is there anything I can take out of all 3 of those numbers? Yeah, I can take out a 2 out of all of these, which would give me a 2, a 1, and a negative 3. At that point, I can't take anything more. So what you notice is that if I can still GCF, greatest common factor, the remainder, that means I didn't take the greatest factor. I took a factor, 4 went into all of them, but it wasn't the biggest. And if you notice, 4 times 2 is 8. If I had divided everything by 8, I end up with 2, 1, and negative 3. So that is my greatest common factor. So don't be so worried about picking the biggest number. Just make sure that when you factor it, you check to see if you can factor again. If the answer is yes, that means you should have taken out a larger factor. So 8 is the first part of our answer. Okay, I'm going to put that actually over here. Now I'm going to look at my variables. My smallest amount of x is x. So that's going to come out of all of them. X cubed divided by x is going to be x squared. X squared divided by x is going to be x. And x divided by x cancels. So there's no x on my last term. Now we're going to do our y. My smallest amount of y is y. So that means I'm going to take out a y as part of my GCF. Divide everything by y. My first term is going to end up being 1y left over. The y's cancel on my other terms. Make sure you have signs between, parentheses, and there is your final answer. Again, always try and do your best at picking the greatest common factor. If you take something out and there's still something I can take out, that means I need to go with a bigger factor. Pause the video now as you try example 10. Press play to go over your answer. The biggest difference on this one is I see I have a negative in front of both of them, so I'm going to go ahead and take out a negative. 18 and 36. Well, if I go through all of the factors, I'm actually going to find that 18 goes into both of these numbers. So I'm going to factor out a negative 18. My smallest amount of variable is x, so I go ahead and factor out an x. My remainder, negative 18 divided by itself is positive 1. X squared divided by x is just x. Negative 36 divided by negative 18 is going to be a positive 2, and x is canceled. So there is our final answer, the GCF, negative 18x, and the remainder of 1x plus 2. Pause the video now as you try example 11. Press play to go over your answer. This is the last one. Do your best. Finish strong. So first we do the numbers. Again, I'm noticing I'm starting with a negative, so I'm going to go ahead and GCF out a negative. I know 6 goes into all of these, so I'm going to GCF out a negative 6. For my variables, I look to my smallest amount of x, which is my last term if it's in standard form, which is just x. Now I find my remainder. I'm going to end up with positive 1, x to the third. Positive 3, x. Positive 4, and that is my final answer. You did a wonderful job. Thank you so much for watching. Make sure you're doing whatever your teacher needs you to do next. Stay awesome.